Today we're going to start section 8.1, Electron Dot Diagrams. I'm only going to get to cover a couple of slides, so please bear with me. Just listen, Oscar. How do we show electrons in atoms? And this might actually appeal to you because it is football related. Diagrams contain a lot of useful information in a compact format. What does the diagram above tell us? Well, it's on the right side for us. It tells us that, so if you look at this, it looks like a football play, right? Oscar, how many players do I got? I got 1, I got 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Definitely a football play, right? The football play diagrammed above describes the lineup of each player on the team and describes how they will move when the ball is snapped. Diagrams of electrons give similar information about where certain electrons are. We mark these electrons and indicate what happens to them when an element reacts. So, why do we do electron dot diagrams? Because just like when Oscar's playing football and he has a play that he needs to run, well, first he needs to know what he's going to do. He needs to look at the diagram and see, okay, my job is to push and keep this guy here, right? Right, Oscar? That's what you do? Electron dot diagrams do the same thing. They tell you how many valence electrons there are so that you can predict if that element is going to share, is going to lose, or is going to gain electrons. Okay? And I'm just going to read this slide and then we're going to stop here. Okay, guys? So just bear with me one more minute. Recall that valence electrons of an atom are the electrons located in the highest occupied principal energy level. Remember that outer orbital where you find valence electrons? You always have to remember highest energy level, meaning what period does that element fall in? That energy level will tell you how many valence electrons are in there. Valence electrons are primarily responsible for the chemical properties of elements, how they react. The number of valence electrons can easily be determined from the electron configuration. Several examples of the second period elements are shown in the table. Okay, so we got lithium, beryllium, nitrogen, and neon. If you'll notice, the highest energy level is period 2, energy level 2. For lithium, there's only one valence electron. For beryllium, there's 2 valence electrons. For nitrogen, there's 2 orbitals in energy level 2, so you're going to have to add 2 plus 3 makes 5. And the last one, neon, again has 2 orbitals, the s and the p, so you're going to have to add those 2 electrons in the s orbital to the 6 electrons in the p orbital for a total of 10. Okay, we'll stop there.